Hello everyone. Welcome back to SmartElectro Academy. We're thrilled to have you join us today. Today, we're diving into a complete home electrical wiring tutorial, covering all the essential components. We'll explore everything from the fundamental wires and connections to the practical installation of sockets and switches. We'll also cover crucial safety devices like MCBs and other protective measures, ensuring your installations are secure. By the end of this tutorial, you'll confidently be able to wire a room safely and professionally, empowering your DIY projects.
Basics of electricity, live, neutral, and earth.
Understanding your home's electrical wiring is crucial for any DIY enthusiast or homeowner looking to tackle projects safely and effectively. Every basic home circuit relies on three essential wires: the live wire, the neutral wire, and the earth or ground wire. The live wire, typically black or red in US wiring, carries the electrical current from the power source to your appliances and outlets. The neutral wire, usually white, completes the circuit by carrying the used electricity back to the power source, maintaining a balanced flow. Finally, the earth or ground wire, often green or bare copper, is a critical safety feature, providing a path for stray electricity to prevent shocks. Always remember, safety first. Never touch live wires and consult a professional if you're unsure about any electrical work.
Correct wire sizes and current ratings.
Hello, homeowners and DIY enthusiasts. Today, we're diving into wire types and ratings to ensure safety. Choosing the right wire is essential, not just for functionality, but to prevent hazards like overheating and fires. Wire size is typically measured in millimeters squared, which refers to the cross-sectional area of the conductor inside the insulation. For instance, 1 millimeter squared is used for lamps, 1.5 millimeters squared for general lighting circuits. 2.5 millimeters squared wires are ideal for standard wall outlets, handling appliances like toasters or hair dryers. For heavy-duty appliances like electric ovens or water heaters, you'll need 4 millimeters squared wire to carry higher current. Using a wire too small for the electrical load causes overheating, damaged insulation, short circuits, and fire hazards. Always consult local electrical codes and, when in doubt, seek advice from a qualified electrician. Prioritizing the correct wire type and size protects your home and loved ones. Stay safe out there.
International color codes and safety rules.
Welcome to an essential guide on electrical safety, focusing on wire color codes for your home projects. Understanding these codes is crucial for anyone working with electricity, ensuring both your safety and the proper functioning of your electrical systems. In most countries, brown is live, blue is neutral, and green/yellow is earth. These international standards are designed to prevent confusion. Correct color coding helps avoid mistakes, which can be incredibly dangerous when dealing with electrical currents. Always switch off the main supply before handling wires. This is the most fundamental safety rule to protect yourself from electric shock. Using insulated tools and wearing appropriate personal protective equipment, like safety gloves, are also vital steps. Regularly inspect cords and wiring for any damage or wear, as frayed wires can pose significant fire hazards. Avoid common mistakes like using incorrect wire sizes or overloading power strips, which can lead to overheating and electrical failures. For complex tasks, or if you're ever unsure, always consider hiring a qualified professional to ensure the work is done safely and correctly. Prioritize safety in all your electrical endeavors. Your knowledge and caution are your best tools.
Switch and socket wiring.
Hello DIY enthusiasts. Today, we're diving into the essential world of electrical switches and sockets, crucial components in every home. Switches control the flow of electricity to lights and appliances, acting as on-off gates for your circuits. Common types include toggle, rocker, dimmer, and smart switches, each offering different functionalities and control options. Sockets, also known as outlets, provide a safe connection point for your devices to draw power from the electrical grid. You'll find various socket types, such as standard 2-prong, grounded 3-prong, and specialized GFCI outlets for wet areas. Beyond switches and sockets, circuit protection devices like MCBs and RCCBs are vital for electrical safety. Miniature circuit breakers, or MCBs, automatically trip and cut off power during overloads or short circuits, preventing damage. Residual current circuit breakers, RCCBs, detect imbalances in current flow, quickly shutting off power to protect against electric shock. Always prioritize safety. Turn off power at the main breaker before working on any electrical components. Use insulated tools, wear appropriate personal protective equipment, and never work with wet hands or in damp conditions. For complex installations or repairs, it's always best to consult a qualified electrician to ensure safety and compliance. Understanding switches, sockets, and circuit protection empowers you to safely manage your home's electrical system. Stay safe and informed.
MCB working principle and tripping protection.
Hello everyone. Today, we're going to explore a crucial aspect of electrical safety. What happens when a circuit overloads and how your miniature circuit breaker, or MCB, protects your home. A circuit overload occurs when too many electrical devices draw more current than a circuit is designed to handle, creating excessive heat. This surge in current can quickly lead to dangerous situations, including overheating wires and potential fire hazards within your walls. That's where your MCB comes in. It's designed as a critical safety device to automatically detect and interrupt the electrical flow. When an overload is detected, the MCB trips, instantly cutting off power to the affected circuit. This immediate action prevents the wires from reaching dangerously high temperatures, safeguarding your home and family from electrical fires. Understanding how your MCB works is key to maintaining a safe electrical environment. Always respect the limits of your electrical circuits.
Room wiring layout planning.
Embarking on a room wiring project requires careful planning to ensure safety and efficiency. First, meticulously plan your layout by marking the precise positions for all lights, fans, and electrical sockets within the room. This initial step is crucial for visualizing the entire electrical system and avoiding costly mistakes later on. Next, you need to decide which specific circuits will share a miniature circuit breaker, or MCB, in your electrical panel. Grouping devices logically helps manage power distribution and makes troubleshooting easier in the future. Finally, and most importantly, calculate the total electrical load for each circuit to ensure it remains within safe operating limits. Overloading a circuit can lead to tripped breakers, damaged appliances, or even electrical fires, so precision here is paramount. Always consult electrical codes and, if unsure, seek advice from a qualified electrician to guarantee a safe and compliant installation. By following these planning steps, you'll lay a solid foundation for a reliable and secure electrical system in your home. Happy wiring, and remember, safety first.
Running wires safely inside walls.
Hello, and welcome to our electrical installation tutorial. Today, we're focusing on the crucial step of running wires safely and efficiently. We begin by starting from the distribution board, the heart of your electrical system. Carefully plan your route to ensure a smooth and direct path for the wiring. Next, run the wires along the walls, ensuring they follow the planned route. This initial placement is key for both aesthetics and functionality. It's vital to fix wires neatly and securely. Use appropriate clamps and clips to hold them firmly in place, preventing any sagging or loose sections. Always keep wires away from sharp edges or damp areas. Sharp edges can abrade insulation, leading to shorts, while moisture poses a significant electrocution risk. Proper wire management isn't just about neatness. It fundamentally ensures safety and durability for the entire electrical system. By following these guidelines, you'll create an electrical installation that is both reliable and safe for years to come. Thank you for watching.
Socket and switch connections.
Switches are simple but critical components in your home's electrical wiring, ensuring both convenience and safety. Understanding their basic operation is key. The live wire enters the switch and then safely goes to the device it controls. Before powering on any newly wired switch, it is absolutely essential to check for continuity to prevent hazards. This crucial step confirms that the electrical path is correctly established and free from any short circuits or breaks. Proper installation, including careful wiring and thorough testing, ensures the long-term safety and reliability of your electrical system. Always prioritize safety and follow best practices when working with electricity in your home.
Before tackling any electrical work, safety is paramount. Always ensure the power supply to the circuit is completely disconnected. Confirm the circuit breaker is off and use a voltage tester to verify no current is flowing through the wires you'll be working with. You'll typically encounter 3 wires: the brown live wire, the blue neutral wire, and the green and yellow striped earth wire. First, connect the green and yellow earth wire to the earth terminal, usually marked with an E or an earth symbol. Next, secure the blue neutral wire to the neutral terminal, often marked with an N. Finally, attach the brown live wire to the live terminal, typically marked with an L. Ensure each wire is fully inserted into its terminal and the screws are tightened firmly to prevent loose connections and potential hazards. A loose connection can lead to overheating or even electrical fires, so always double-check your work. Before restoring power, visually inspect all connections one last time to confirm everything is correctly and safely installed. With these steps, you can confidently connect electrical sockets safely and correctly. Always prioritize safety in all your DIY electrical projects.
Multimeter testing methods.
Once all connections are done, it's crucial to test each point with a multimeter to ensure your circuit is safe and functional. This essential tool helps us verify voltage, continuity, and proper earth connections. First, let's check for voltage. Set your multimeter to the appropriate voltage range. Then carefully place the probes across the components or points you want to measure. A stable reading within your expected range confirms power is flowing correctly. Any unexpected high or low readings could indicate a problem. Next, we'll test continuity. Switch your multimeter to continuity mode, often indicated by a sound wave or diode symbol. Touch the probes to 2 points that should be connected. A continuous beep or a reading close to 0 ohms means there's a good electrical path. No beep or an OL reading suggests an open circuit. Finally, checking earth connections is vital for safety. Use your multimeter to confirm a low resistance path between the earth terminal and any metal enclosure or chassis. Proper testing ensures your DIY electronics projects are not only functional, but also safe for everyone.
Proper earthing systems, TT and TN.
Earthing is absolutely crucial for electrical safety in any setting, protecting both people and equipment. Its primary function is to safely carry fault current away from devices, preventing dangerous electrical shocks and potential damage. Without proper earthing, a fault could energize the appliance's casing, turning it into a hazardous live conductor. There are several common earthing systems, such as TT and TN, each designed with specific configurations for different applications. The TT system uses a direct connection to earth at the installation, independent of the supply network's earthing. Conversely, TN systems connect the protective earth conductor back to the supply transformer's neutral point. Each system has its proper setup and requires careful installation to ensure maximum safety and compliance with regulations. It is absolutely vital to ensure that all metallic appliances and conductive parts are correctly connected to earth. This includes everything from large industrial machinery to common household appliances, providing a critical path for fault currents. Proper earthing is not just a recommendation. It's a fundamental safety measure that protects lives and property.
Common wiring mistakes and how to avoid them.
Hello, DIY enthusiasts. Today, we're diving into common electrical mistakes that can turn a simple home project into a dangerous situation. One of the most frequent errors is using the wrong wire size for your circuit. This can lead to overheating and potential fires. Always match the wire gauge to the circuit breaker's amperage rating to ensure safe and efficient power delivery. Another critical mistake is making loose electrical connections. These can cause arcing, which generates intense heat and sparks. Ensure all connections are tight and secure, using appropriate tools to prevent any gaps or movement. Forgetting to use a ground or earth wire is a serious safety oversight that can lead to electric shock. The ground wire provides a safe path for electricity in case of a fault, protecting you from harm. Finally, overloading circuits is a common hazard. Plugging too many high-power devices into one circuit can trip breakers or worse. Distribute your electrical load evenly across different circuits to prevent dangerous overloads. By avoiding these common electrical mistakes, you can ensure your DIY projects are both successful and safe.
Electrical troubleshooting techniques.
Experiencing electrical issues at home can be frustrating, but understanding basic troubleshooting can help you identify and resolve common problems safely. If you notice lights flickering or your miniature circuit breaker, or MCB, frequently tripping, these are clear indicators of underlying electrical issues that need attention. One common culprit is loose connections. Over time, wires can become dislodged from outlets, switches, or fixtures, leading to intermittent power or overheating. Always check that all connections are secure and properly tightened to ensure a consistent and safe flow of electricity throughout your home's wiring system. Another critical factor is wire size. Using wires that are too small for the electrical load can cause them to overheat, posing a significant fire hazard. Ensure your wiring matches the amperage requirements of your circuits and appliances to prevent dangerous situations and maintain system integrity. Faulty devices are also frequent causes of electrical problems. A malfunctioning appliance or fixture can draw too much current, causing your MCB to trip. Systematic troubleshooting involves unplugging devices one by one to isolate the faulty item, helping you pinpoint the exact source of the issue. Remember, safety is paramount when dealing with electricity. Always turn off the power at the main breaker before inspecting or working on any electrical components. By following these step-by-step troubleshooting tips, you can safely identify and address many common electrical issues, ensuring a safer and more reliable electrical system in your home.
Complete safety devices recap.
Did you know that hidden dangers lurk within your home's electrical system, posing risks to your safety and property? Fortunately, our homes are equipped with silent guardians, essential electrical safety devices designed to protect us. First, let's talk about miniature circuit breakers, or MCBs, which are crucial for preventing electrical fires. These devices automatically switch off the electricity supply during overloads or short circuits, acting as your home's vigilant guard. Just like a watchful protector, MCBs ensure that dangerous electrical surges are immediately contained, keeping your household safe. Next, we have residual current circuit breakers, or RCCBs, which play a life-saving role in preventing electric shocks. These sensitive devices detect even small leakages of current, which can be incredibly dangerous if they pass through a person. By quickly cutting off power, RCCBs prevent severe injuries or fatalities from accidental contact with live wires. Traditional fuses, while older technology, still serve a purpose by melting and breaking the circuit during overcurrents. However, they are single-use and must be replaced, unlike the resettable MCBs and RCCBs. Equally vital is earthing or grounding, which provides a safe path for fault currents to flow away from your home. This prevents dangerous voltage buildup on metal parts of appliances, protecting you from potential shocks. Together, MCBs, RCCBs, fuses, and earthing form a comprehensive safety net, guarding your home and loved ones. Don't leave your electrical safety to chance. Have your electrical systems checked by a qualified professional today.
We covered wires, switches, sockets, MCBs, earthing, and safety. Remember, plan first, wire correctly, always test, and never ignore safety. Before electrical work, safety is paramount. Turn off the power at the circuit breaker. Use a non-contact voltage tester to confirm power is off before touching any wires. This prevents serious accidents. Now, let's tackle wiring a light switch. Connect the hot, neutral, and ground wires correctly. First, strip about ½ inch of insulation from each wire using a wire stripper. Careful not to nick the copper strands. Next, connect hot wire to brass screw, neutral to silver screw, and ground wire to green screw on the switch. Ensure all connections are tight and secure. Loose ones can lead to arcing and fire hazards. Finally, push the switch into the electrical box, secure with screws, and install the cover plate. Like, comment, share, and subscribe to SmartElectro Academy for more tutorials. Stay safe and keep learning.